Now we will design an Armstrong FM transmitter for a given specification. The given specification is as follows. The narrowband carrier frequency FC1 is 0.1 megahertz and narrowband frequency modulation, that is narrowband frequency deviation, is 10 hertz. This will be the 10 hertz. This will be 10 hertz. Another specification is to generate an FM wave. The final carrier is to be 100 megahertz. This is to be 100 megahertz. And final frequency deviation delta F, this is to be 75 kilohertz. This is the standard frequency deviation for a commercial radio transmitter. Now, our design parameters are this frequency multipliers N1 and N2. Now, we have to find out these parameters N1 and N2 such a way that it is suitable according to our existing frequency multipliers. Normally, frequency doublers, frequency triplers and frequency quadruples and so on are available. So based on that, we can factorize this N1 and N2. Now we have to find out N1, N2 and also F0 here. If F0 is given in the question, then you need not find out F0. According to F0, you have to calculate N1 and N2 here. Now let us assume that F0 is given as 8.5 megahertz. So this is 8.5 megahertz. This is 8.5 megahertz. Now let us proceed to find out the value of N1 and N2. See, we are starting with a frequency deviation of 10 hertz. Frequency deviation of 10 hertz. And we have to reach a frequency deviation of 75 kilohertz here. So what is the multiplication factor required for this 10 hertz to reach here as 75 kilohertz? That is 75,000 divided by 10 hertz. So multiplication factor required is 7,500. So the total multiplication factor required is 7,500. So this 7,500 we have to factorize into N1 and N2 such a way that it is a power of 2, it's a power of 3 or power of 4 or power of 5 depending on the multipliers available with you. Now this can be written as 100 into 75. This can be written as 100 into 75. Now out of this, which is N1 and which is N2 we don't know. Whether 100 is N1 and 75 is N2 we don't know. That can be found out by making use of this local oscillator frequency information and the final requirement of this carrier frequency. Now you see here, of course, with this 100 here or 75 here or 100 here or 75 here, we can fulfill the requirement of the frequency deviation at the output. But can you fulfill the requirement of having 100 megahertz carrier wave here? So for that what we do is, let us try to put 100 here and 75 here. Let us try to put 100 here and 75 here. Now when you put 100 here, what is FC2? So FC2 is equal to 100 times FC1. That is 100 into 1 megahertz. So you get 100 into 0.1 megahertz. So 100 into 0.1 megahertz. So you get 10 megahertz, right? So the value which you get here is 10 megahertz. So value you get here is 10 megahertz. Of course, delta F2 will be 100 into 100 hertz, 10 hertz, it will be 1 kilohertz, you get it here. Now, you can see here that you have 8.5 megahertz here. So difference will come here. So difference means you have 10 megahertz minus 8.5. So what comes here is 1.5 megahertz. It is 10 minus 8.5 megahertz. What comes here is 1.5 megahertz. Now, what is requirement here? Requirement here is 100 megahertz. Right? So here you have 1.5 megahertz. So FC4 is equal to N2 times 1.5 megahertz. So what we have taken it as 75 here. So now 75 into 1.5 megahertz. So if you multiply this 75 and 1.5, so what are you going to get? You are going to get 112.5. 112.5, which is not the desired one. Which is not the desired one. This is not the desired one. But desired one is 100 megahertz. So our selection of taking N2 as 75, N1 as 100 is not going to satisfy the requirement. So what we do is, we will change it. So now what we will do is, we will just change this. N1 will change it to 75 here. So what we'll do is, we'll just make this as 75 and we will make this as 100. Will this make it as 100. Now let us see we will be able to get a proper value or not. We will remove all these things. This will change according to now for this value, what is FC2? FC2 is equal to 75 times FC1. So you will have 7.5 into 0.1 megahertz, 75 into 0.1 megahertz. So you will get it as 7.5 megahertz. So what you get here is 7.5 megahertz. So what is the delta F2? So delta F2 is 75 times delta F1. So 75 into 10. So 750 hertz, you get 750 hertz here. Now you see here, after the frequency converter, you're going to get the difference of this. So you get 8.5 minus 7.5. So that is nothing but FC3 it is 1 megahertz. FC3 is equal to the difference between this frequency FC2 and this local oscillator frequency. So 8.5 minus 7.5, you get it as 1 megahertz. What is delta F3? Delta F3 will not change. Delta F3 will remain same here. Only frequency is converted. Frequency deviation is not going to change. So delta F3 now is 750 hertz only. Now you see whether you are going to get required specified carrier frequency or not. Now multiply this. 1 megahertz into 100, you get 100 megahertz. 750 into 100, you get 75 kilohertz. Finally, now we can say that your N1 is equal to 75 and N2 is equal to 100. So you can just factorize this once again as a power of 2 or power of 3, power of 4. So this can be written as something like 3 into 5 to the power of 2. So this you can write it as 5 to the power of 2 into 2 to the power of 2. So this is making use of frequency triplets, frequency doublers, and also the multiplier which multiplies the signal by 5 times. So this is the final answer for this particular design. So here we have designed an Armstrong FM transmitter. Hope you like this video. If you like this video, so send me a feedback about this video so that this type of lecture can be further improved.